Okay, we're going to wrap up section 2.4 with a continuation of sketching our slope curves, our derivative functions. So we were looking at this function f of x in part C, and we had said our slopes are negative, then 0, positive, then 0, negative, then 0, and positive. So when I refer to negative slopes, say between 0 and 2, that's why my derivative function is below the x-axis. From 2 to 4, my slopes are positive, and so my derivative is above the x-axis. Okay, last graph. Looks like we have a 0 slope at negative 2. Somewhere in here, it looks like I have a 0 slope. I'm going to estimate that about here. The slopes between negative 4 and negative 2 are positive. The slopes between negative 2 and negative 1/2 are negative. The slopes from negative 1/2 on are also negative. Okay, but we're saying that at negative 1/2, roughly the slope is 0. Okay, so drawing this derivative graph, we need positive slopes to 0, and we need negative slopes. Somewhere in there we're going to get the biggest negative, and then we get to 0. But we don't go positive, we go back negative again. So positive slopes to 0, negative slopes, 0, and negative slopes again. Okay. Practice. Sketch the graph of a function that is consistent with this data. So first of all, in the first 2 rows, we're just looking at an xy ordered pair. So we can plot those points. So at negative 2, we're going to be at positive 1. At negative 1, the graph is at negative 1. At positive 1, the graph is at negative 1. And at positive 2, the graph is at 2. Okay, next, we have slopes given to us. So at these points, I'm going to attempt to make slopes that match what's given. So we need a slope of a negative 3. Okay, so that's pretty steep at this point, and that's not very good. I'm going to try that again. Maybe more like this. Right, you can see it continuing down, continuing up. So I'm just estimating slope is negative 3. So I'm just going to draw these little tangent lines, and then I'll hook things together. All right, negative 1, the slope is 0. Positive 1, the slope is negative 1. It's a little steep, but we'll go with it. At 2, 2, the slope is a negative 2. So you could imagine hitting these points. All right, so I need to connect these red little tangent line slopes together to make this function be sort of flowing. Okay, so I'm going to start and connect. I know I have to get to a 0 slope. Somewhere I have to come up so that I can get down to this slope. Now this is a real stretch here. I think I'm going to just jump up here and come back down. Not very smooth and fluid like some of the other graphs that we've seen, but it satisfies the criteria. Okay, write an equation of the tangent line to the function at negative 2. So we'd like to use point slope form. Do you know the point in question? Yes, I do. It's negative 2, f of negative 2, which is 1. Do you know the slope at this point? Yes, I do. The slope is -3. So if I use point slope form, I'm going to say y is equal to -3, quantity x plus 2 plus 1. Okay, we're going to look at one more page, and I'm going to leave the last page for practice for you. Okay, number 2, the tangent line to the function f at 5, 2 passes through the point 0, 1. So the tangent line to a function at this point on the function passes through the point 0, 1. Find f of 5 and f prime of 5. Well, f of 5, that's an easy one because I think it's given to us. F of 5 is the y value when x is 5, and that is given to us as 2. That's the coordinate 5, 2. Now f prime of 5, that is the slope, or the derivative at x equals 5 on this function. Now I don't have a function, I don't have a graph, but I do know that the tangent to this point passes through this point. So I could use the two of these to find the slope of the tangent. All right, so 1 minus 2 over 0 minus 5 will be -1 over -5, or 1/5. So the slope of the tangent is 1/5. That is f prime of 5. Okay, number 3. Suppose that f prime of x is greater than or equal to 0 on the interval from 2 to 7. Explain why f of 3 must be less than or equal to f of 6. Okay, I don't know what the graph looks like, but I do know the slopes are positive. They could be 0 and positive again. Or it could just be, positive the whole time. Doesn't have to be a straight line, but positive the whole time. So any of these could be what f of x might look like. All right, on the interval from 2 to 7. So I'm just going to pick this graph here. This one to the right. So x equals 3 has to come before x equals 6. And so this point would be 3 f of 3. This point would be 6 f of 6. Okay, so if the slope is positive, then the function must be increasing. So that means y values are getting bigger and bigger as you move from 3 to 6. All right, so since 2 is less than 3, is less than 4, is less than 5, is less than 6, is less than 7, right? Thinking of that on your x-axis. F of 2 must be less than f of 3, must be less than f of 4. And continuing on. Okay. The other thing, the way I would like to think about it is, well, if you take a look at the slope between these 2 points, I would figure out f of 6 minus f of 3 over 6 minus 3. Now I know since f of x is increasing, that f prime of x is positive. So I'm just going to say that this slope expression is positive. And if I cross multiply by the denominator of 3, or eliminate the denominator of 3, I get f of 6 minus f of 3 is greater than 0, which means f of 6 is greater than f of 3. Okay, which also means that f of 3 is less than f of 6. Okay, check. All right, number 4. Draw a continuous function that satisfies the following 3 conditions. So continuous means you can sketch the curve without ever lifting your pencil. Okay? All right, so here we go. F prime of x is positive when x is less than -2. So here's -2, and I know f prime is greater than 0 in this region. So the slopes are positive. My function must be increasing. So f increasing. Right? I'm just going to abbreviate for us here. F prime of x is less than 0 between -2 and 2. So here's 2. And I know f prime is less than 0. That means the slopes are negative. That means f is decreasing. Y values are going down. F prime of x equals 0 when x is greater than 2. F prime equals 0. That means we have a zero slope. Okay, so no increasing or decreasing. We must have a flat horizontal. For f of x. Okay, so it just says sketch it, doesn't give us any y values. So we can make them up. So I need to have f increasing. So here we go, f is increasing and has to get to 0 because it's got to change to negative. F is decreasing and getting to 0, and then it's flat. So it could look like this. And that graph could be higher or lower because we don't know any y values. So it could just be a shift. All right, any of those could be f of x. All right, the graph of f is given. This is my function, f of x. Sketch f prime. All right, remember my strategy? Find the zeros first. Then decide if the slopes are positive or negative. Slopes are negative. Slopes are positive. Slopes are negative. Slopes are positive. So function for the derivative must be negative. And then positive. I don't really like that. I'm going to start that over. It looks pretty small. Okay, positive slopes going to 0. Negative slopes, somewhere between there's the biggest negative slope, and then positive slopes. Continuing. Okay, this last page is for you. I want you to try these on your own, drawing the derivative graph, and then I want you to see if you can notice any patterns. Okay, line, parabola, cubic, maybe a sine function, some other various things going on. Okay, find the derivative graphs and have fun with that.